going to build on the idea of the indefinite integral now to develop something called the definite integral. To see where this is coming from, let's suppose that a company's profit in thousands of dollars has been growing according to the function p of t equals 3t cubed minus 2t squared, where t is the number of years since the company was founded. We want to know how much profit was accumulated during the second 2 years. In other words, from time t equals 1 to time t equals 3. So let's let capital P of t be the profit function. Notice that little p of t is how the profit is changing, how it's growing. We want to think about the actual profit function now. So the profit accumulated during the second 2 years is going to be capital P of 3 minus capital P of 1, because we're computing profit after 3 years minus the profit after 1 year. Let's notice that little p of t was the rate of growth for capital P of t. That means then that little p of t is the derivative of capital P of t. And to turn that idea around, we could then say that capital P of t is an antiderivative of little p of t. Right? Because if you differentiate a function to get little p of t, then that function is called an antiderivative of little p of t. So that means we can actually compute a formula for capital P of t. Since it's an antiderivative of little p of t, it is the antiderivative or an antiderivative of 3t cubed minus 2t squared dt. So it must be t to the fourth power minus t cubed plus a constant. Now, we don't have enough information to know what that constant is, so we can't totally pin down what the profit function is, but we can get pretty close. And even though we don't know what that constant is, let's go ahead and compute P of 3 and P of 1 and see what happens if we subtract them. So P of 3 would be 3 to the fourth minus 3 cubed plus c, which is 54 plus c. And capital P of 1 would be 1 to the fourth minus 1 cubed plus c, which is 0 plus c, which is just c. So if we subtract those two things to find out the change in profit between the 2 years, or the difference in total profit between the 2 years, we have 54 plus c minus c, which is 54. And something to note is that the c's will always cancel when subtracting two antiderivatives. So even though we don't know what c is, meaning we don't know what the actual profit function is, we can still determine that the company accumulated $54,000, because this was given in thousands, $54,000 of profit during its second 2 years. This is the kind of problem we'll be working on in this section. And there's some notation that goes along with this type of problem. To set up the context, let's suppose we have some function capital F of t. And when I differentiate it, I get a function little f of t. In other words, little f of t is the derivative of capital F of t, and so we say that capital F of t is the antiderivative of little f of t. The notation we've developed for that is this integral. So the integral of little f of t, remember you get the antiderivative of little f of t plus some arbitrary constant. Now in the profit problem we just did, what we were interested in was the difference of between two values of the antiderivative. So suppose A and B are t values. And we want to know what f of b minus f of a is. We've seen that we can compute f of b minus f of a by taking the antiderivative of little f evaluating that antiderivative and then plugging in our two t values. So there's a notation for that where you indicate you're going to do that by putting a little a underneath the integral sign and a little b on top of the integral sign. So what's going on here is I'm defining some new symbols here. This is defined when you put the little a's and b's in. What we're saying, this is defined to be not just capital F the antiderivative, but specifically plug in those two numbers, a and b, and then subtract. There's another notation for f of b minus f of a, and it looks like this. Capital F of t, and then you have a vertical line with the a and the b. So if you put these notations together, we've got this new kind of integral which is called the definite integral, as opposed to the indefinite integral. It's defined to be what you would get if you take the antiderivative and plug a and b in and then subtract. And the notation for doing that plugging in and subtracting looks like capital F of t, the antiderivative, vertical line, and the two numbers. It's always confusing when you get a bunch of new notation, so let's see some examples to get a better feeling for how this works.